Applying chain rule to find the derivative of a function is hard enough as it is. So what happens when you have to apply chain rule twice in one problem, or sometimes even more than twice in one problem, to find the derivative of a function? That's a real pain, right? Well, in one of my recent weekly live streams that I do every Monday night, I went over an example of applying chain rule twice in one problem and touched on how you can actually apply this same method for any type of problem where you have to apply chain rule even more than twice in the same problem. And I broke it down in a way that I think should make it a lot easier for you. So I wanted to show you that problem again and just kind of go over how to deal with the type of problems where you have to apply chain rule twice. So if this is something that you're having a hard time with, be sure to stick around to the end of the video, and I'm sure by the end you'll be feeling a lot better about it. Anyway, let's go ahead and jump into the problem and I'll show you what I'm talking about. So again, we're going to go ahead and use the chain rule to find the derivative of this function y equals sine of x. So this is a pretty interesting example. It's still going to be able to be found using the chain rule because we have a composite function. But this is a very interesting one because we have more than just a single inside function and a single outside function. We actually have three functions now plugged into each other, basically like three levels of composite functions, basically. So this is a pretty interesting example. And I have made another video about kind of the same idea of how to do chain rule when it's more than just one inside function and one outside function. But I'll kind of talk about that a little bit more here. In terms of our approach that we've been taking here, where we're just thinking about kind of this one easy method to remember, the chain rule formula of just saying, derivative of the outside function, leave the inside function alone, times the derivative of the inside function. Well, again, what we want to do is kind of think about the inside most function and work our way out. And we'll kind of think about it, step by step. So again, my main trick for doing that is start with where your variable is. Start with where x is. In this case, we only have an x right here. We don't want to just ever say our inside function is x. That doesn't really help us. We need it to include more than just x. So what we can do is if we, think about our order of operations, if we were to plug some number in for x here, we would first deal with sine of that number. We would deal with this first sign here. So basically this innermost parentheses would be the first thing we'd deal with. So let's go ahead and call that our first level of inside function. Next, once we figured out what that first sign of x is, what would we deal with next? Well, we would just work our way out one level outside of the next set of parentheses, and we would do sine of that thing. So then we would deal with this second sign, basically. So we'll go ahead and say that this is now our second most inner level. Then, once we figured out what sine of x was, we would work our way out one more set of parentheses. So then we would deal with this sign out here. So this would be like our, third most inner function, or in this case, our outermost function. So we have these three levels, the innermost, the middle, and then the outermost function. We're still going to use the same kind of method that I've been describing, except instead of thinking of it as just derivative of outside function, leave the inside alone, times the derivative of the inside, we'll kind of think of it as outermost and then the next level to the inside. So what I mean by that is, first, we're going to go ahead and think of finding the derivative of our outside function, our outermost function, I should say, our third level function. So in this case, it's sine of all this stuff. But we're going to use that same trick where whatever the next level of inner function is, so in this case, our 2 circle, our orange circle of number 2, we're going to replace all of that with x. So basically, if we think of our outermost function, in this case, it's going to be sine of x, because if we replace the next level of inner function with just x, we just get sine of x. Okay? Same kind of idea. If we think about what is our outer function, if we just look at this kind of centralized, just these first two layers, right? If we replace our innermost function with just x, which is this first sign of x here, we're just left with sine of x, right? If we replace this whole green circle with x, the orange function becomes sine of x, okay? And then our innermost function that's the easiest one. Our innermost function is just everything within this innermost green circle here, which is also sine of x. So basically our inner function is sine of x, our middle function is sine of x, and our outermost function is sine of x. So how does chain rule tell us to deal with this? Well, chain rule says that we're going to take the derivative of our outermost function, so the derivative of sine. The derivative of sine is going to be cosine. We're going to take the derivative of our outer function, leave our inner function alone. So we're going to leave our second layer of function and everything within it. So when I'm talking about our middle function here, that kind of includes this first level function within that already. So we're going to leave our inside function alone. Well, our inside function in this case is sine of x. So we're going to leave this inner function sine of x alone, okay? Then we multiply that by the derivative of sine of x. So basically we would then multiply that by the derivative of sine of x. But now look at when we have here the derivative of sine of x. Now this derivative, just this one little chunk of our problem right here, is going to require the use of the chain rule, because now we have an inside function and an outside function. Okay, so now just to find this derivative piece here, we need to again apply chain rule. So we'll go ahead and leave all this over here. So we're going to leave cosine of sine of x. That's just going to be left alone out there. Now we're going to have to apply chain rule basically a second time to find the derivative of sine of x. So again, chain rule says we're going to take the derivative of the outside. The derivative of our outside function is the derivative of sine of x is cosine of x. So we're going to take the derivative of the outside function, which is cosine, leave the inside function alone. So we're going to leave this inside sine of x as sine of x. Then we're going to multiply that by the derivative of the inside function. Well, again, the derivative of our inside function, which is sine of x, is cosine of x. So now we get this whole thing times this whole thing. So now our derivative of our original function is going to be kind of these three separate pieces, which we get from each layer of working through the chain rule. So this is the derivative of our outermost function, leave the inner two alone, times by the derivative of the inner two, which the derivative of the inner two is the derivative of the middle, leave the innermost alone, and then times by the derivative of the innermost. So you're basically just starting with the outermost function and working your way in one function at a time. And each time basically leaving all the functions that are, more inside of that layer as they are alone, just leaving them alone. So hopefully that kind of clears that up a little bit. But this is going to be now our y prime. So this same method could basically be applied if you had even more layers, right? So this case, we just had 3 layers. Theoretically, we could do this exact same process with like 5 layers, right? Like if we had y equals sine of sine of sine of sine of sine of x. And I know that seems crazy, but it's the exact same idea. You would just start with the outermost function. That would be your outer function. All this would be your inner function. Then when you're taking multiplying by the derivative of your inside, you would treat just this as your outer function and all this as your inner function. Then when you multiply by the derivative of your inside, you treat just that as your outermost and treat all that as your inner. And then again, so you're just kind of working one layer further and further in. You would end up with these like 5 different things being times by each other by the end of the process. And you would end up with this same kind of thing where it's each piece just getting a little bit more simplified because you're dealing with one fewer sign plugged into that. So I'm not going to go through this example, but I think this would be a fun example if you want to kind of test this out on your own. Go ahead and see if you can find the derivative of this function. using the same process that we just went over with this example up here, finding this derivative. Well, that wasn't so bad after all, was it? Hopefully you're feeling a lot better about it now that you saw this whole video. Thanks for sticking around to the end. If you want to keep learning about chain rule or some other methods of taking derivatives that I think you'll find quite helpful, just go ahead and click on one of those videos over there. And if you got some value out of this video and you're feeling much better about using chain rule twice in one problem, hit that like button down below before you leave. Thanks, and see you next time.